The next thing we're going to take a look at in this unit is how to simplify square roots. You've seen this in Algebra 1. I'm going to kind of review how this works, although I may show you a slightly different way because the method I'm going to show you will make it easier then for us to move in future units to cube roots and fourth roots and all of that stuff. And basically we're doing this because starting in the next unit, when we start solving certain types of equations, we might have square roots in our answer. And I don't want to give decimal answers. I want to try to simplify my square root to write it with the smallest number of numbers possible. Before we do this, though, I want to make a list of the first 15 perfect squares. 1 squared is 1. By the way, we're on page 11, section 2.2 in the notes. 1 squared is 1. 2 squared, 2 times 2 is 4. 3 squared is 9. You're going to say these along with me at home, right? Good. Wonderful. 4 squared is, oh, I know you just said 16. 5 squared is 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared, 196. Basically, if you know one, you kind of know the other. They just switch the digits there. 15 squared, 225. I'm not going to care so much about 1 squared equals 1, but the rest of these numbers are going to help us as we go to simplify our square roots. Square root of 25 is asking the question, what number squared, what positive number squared gives us 25? And we know that's going to be 5. But the square root of 24, it's not going to be a nice whole number. If you go to the calculator, you'll get a decimal for that. But I want to try to give a simplified square root for that. Here's what we're going to do. And I'm going to fill in the process as I go to do that example. To simplify a square root, number 1, I'm going to take the number inside my square root, and I'm going to try to write it as a perfect square times the, I'll just call them the leftovers. Step number 1, write the number inside the square root. As a perfect square, one of the numbers on the list that I just created, times the leftovers. The first thing I'm going to do is I'm going to write the number inside the square root as a perfect square times the leftovers. Well, here's what I mean. Square root of 24. I want to try to write 24 as one of these numbers times something else. Well, I think I can say 24 is 4 times 6. So I'm going to do that. I'm going to write this as the square root of 4 times 6. Perfect square, leftovers. Step number 2. I'm going to take the square root of the perfect square and move that outside the root. Take the square root of the perfect square and move it outside the root. Step number 2, we're going to take the square root of the perfect square and we're going to move it outside the root. The square root of 4 is 2. So I'm going to move a 2 outside my root, and I'm going to say 2 root 6. There is a third step. It's not going to matter here, but it will matter in other problems. I'm going to continue until what's inside the root can't be simplified further. Continue until what's inside the root can't be simplified further. Continue until what's inside the root can't be simplified further. So I'm looking at that 6. Can I write that as 4 times something? No. 9 times something? Don't even bother checking that because that's bigger than my number. This is as simplified as we can get. Get this in your notes. So you might have seen this in Algebra 1 by like making some trees or something like a 3 and an 8 and a 2 and a 4 and a 2 and a 2, and then you circle the pairs and that goes. I think I would like to see if you can try to get used to this other method again, because it's going to make other types of roots later on a lot easier to deal with if we don't have to make those trees, but can just sort of go through our list of perfect squares. Letter B, square root of 48. Well, you can write 48 as what perfect square times something else. Can you submit to Edpuzzle the multiplication problem that you're going to get under your root? A couple different ways you could do it. I'm going to say 4 times 12. There's another way you could do it. I'll show you that in a moment. If you say 4 times 12, you're going to get 2 root 12. However, we're not done. We would then need to rewrite 12 as, okay, what perfect square is inside there? I can divide it by 4. I can say 4 times 3. Square root of 4 is 2, so I'll move another 2 out front. I've got 2 times 2 root 3, and I'm going to get 4 root 3. You might have found a bigger number. If you tried to do this by saying, well, it's just 16 times 3, we can do that. We can say square root of 16 times 3. What is the square root of 16? It's 4. 4 root 3. You'll get the same answer. You'll just get there a little bit quicker. I don't really care if you find small numbers and just take a few more steps, or a big number and do it in one step. Just make sure, though, you are showing this work. Show me how you're breaking down the stuff inside the roots, and then show me what's getting moved out and what's staying inside. Letter C. See if you can simplify letter C completely, and then I'm going to ask you in Edpuzzle what's outside the root and what's inside the root. I'm going to write 63 as 9 times 7. Square root of 9 times 7. Square root of 9 is 3. 3 root 7. Try letter D, and again in Edpuzzle I'm going to ask you what's outside the root and what's inside the root in your final answer. A couple ways you can break this down, but I'm going to say 9 times 20. Square root of 9 is 3, so 3 root 20. I'm going to keep going. I'm going to get 3 root 4 times 5. Square root of 4 is 2, so 3 times 2 root 5. 6 root 5. Could have done it in one step by saying 36 times 5 and then move that out front. But you should have a 6 outside the root and a 5 inside the root. So this is how we simplify square roots of numbers. I actually think it's easier to try to simplify square roots with variables. Next page. Square root of x squared is like asking what squared gives you x squared. Don't think too hard. Square root of x squared, just x. The square root of x to the 6th is like asking what squared would give us x to the 6th. And well, I think x to the 3rd squared would give us x to the 6th. So the square root of x to the 6th is x to the 3rd. And really, all we have to do is just divide the power by 2. With that in mind, the square root of x to the 10th, y to the 6th, is going to give us x to the 5th, And y to the y to the third. We'll just divide the power by 2. To take the square root of a variable with an even power, as long as our power is even, we are just going to divide the power by 2. Not so easy, though, when it's an odd power. Well, still not terrible, but not quite that easy when it's an odd power. Because 5 divided by 2 is 5 halves, 11 divided by 2, 11 halves. We will deal with fraction powers, but not till quarter 4. But here's what we can do. I can use a similar trick that I used with my numbers. I can break this down into a perfect square times the leftovers. I can say that x to the 5th, well, to be a variable that I can take the square root of, I need an even exponent. I can say that x to the 5th, by my laws of exponents, is x to the 4th times x to the 1st. Because isn't x to the 4th times x to the 1st, don't you add the powers when you multiply, so wouldn't you get x to the 5th there? I can then take the square root of x to the 4th. Because it now has an even power, I can divide that power by 2, and I'm going to get x squared, square root of x. Let me show you another. Square root of x to the 11th, this is not an even power, but I want to write it as an even power times, well, the leftovers, which will always just be an x to the 1st. I'm going to write this as x to the 10th times x to the 1st. I now have an even exponent over here, so I can take the square root of x to the 10th by just dividing the exponent by 2, x to the 5th, square root of x. To take the square root of a variable with an odd power, we are going to rewrite as the square root of x to an even power times x. And then I guess we'll say, take the square root of the square root of x to the even power, which really just means divide the power by 2. Let's get that in the notes, and then we'll do a few examples. So we're going to do A together, and you're going to try B on your own. I need to go, and any even variables will be okay. And, no, sorry, any variables with an even power will be okay, and any variables with an odd power I'm going to need to rewrite. X to the 13th, I'm going to need to rewrite. And by the way, I will need to see this work. X to the 13th is going to become x to the 12th times x. Y to the 14th was already good, so I'm just going to leave that for now. I'll do the square root in the next step. I'll just say y to the 14th. Z to the 15th, odd power, no good. I'm going to say z to the 14th times z. I can now take the square root of x to the 12th, y to the 14th, and z to the 14th. To take the square roots of those variables with even powers, I'll divide my power by 2, and I'm going to get x to the 6th, y to the 7th, z to the 7th, and inside the root, you're going to get an x and a z. See what you can do in letter B, and make sure you're showing you're breaking down work. So those powers happen to be perfect squares, but that doesn't actually matter because I don't care about that with exponents. I care about even exponents versus odd exponents. So I'm just gonna go. A to the 16th is good. I'm going to leave it for now. I'll deal with it in a moment. B to the 25th, I'll say b to the 24th times b. C to the 49th, c to the 48th times c. Square root of a to the 16th, divide the power by 2, we get a to the 8th. Square root of b to the 24th, divide the power by 2, we get b to the 12th. Square root of c to the 48th, we get c to the, divide the power by 2, we get 24. Inside our root, we're left with a b, and we're left with a c. One more thing in this section. Simplifying square roots with numbers and variables. All we really need to know is we use our number rules on the numbers and the variable rules on the variables. 312, I want to rewrite that number as a perfect square times the leftovers and deal with that. And as for the variables, I want even powers, and if they're not, I'll rewrite as an even power times x or y or z just to the first. So see what you can do in letter A. I'm just going to kind of work my way through the list. I can divide this by 4, so I'm just going to do that. 4 times 78. If you have no idea what you're doing, just work your way through the list. Can you divide by 4? If not, try 9. If not, try 16. Although actually, if 4 didn't work, 16 won't work. If that doesn't work, try 25. And keep going through the list. You shouldn't usually have to go too far until you find something that works. Certainly never higher than 225. I'm going to get 4 times 78, x to the 4th. Y cubed I'll write as y squared times y. Z to the 11th, I'll say z to the 10th times z. I'm going to underline the things I can take the square root of just so I don't lose them. I'm going to take my square roots. I'm going to get a 2 out front. X squared, y, z to the 5th. Inside my root, I've got a 78, y, z. And that's all we're going to do there. Letter B, there's already some stuff out front before the root. Whatever, we're just going to leave it. And as we move things out, we'll just multiply this stuff by the additional things I move out. See if you can do your rewriting in letter, actually see how far you can get in letter B. See if you can finish that one. I can say 9 times 6. X to the 3rd is x squared x. Y to the 7th is y to the 6th times y. I can do the square root, I can do the square root, I can do the square root. I'm just going to leave that negative 2x squared y out front for the moment. I'm going to move out a 3, an x, and a y to the 3rd. And inside my root, I'm left with a 6xy. Outside now, I'm just going to multiply. Negative 2 times 3 is negative 6. X squared times x is x to the 3rd. Y times y to the 3rd is y to the 4th. And inside, we get square root 6xy. Make sure when you're doing these shouldn't be super difficult, but I do have to see the work. I will not give you credit if you just give me answers with no work. I need to see the breaking down work for the numbers. I also, though, need to see the breaking down work for your variables.